Okay, 35. Great example of needing to read through the whole problem to really understand what's happening because it's a topic that we don't ever, probably never thought about. Keeping water supplies clean requires a regular measurement of levels of pollutants. The measurements are indirect. Typical analysis involves forming a dye by a chemical reaction with the dissolved pollutant, then passing light through the solution and measuring its absorbance. To calibrate such measurements, the laboratory measures known standard solutions and uses regression to relate absorbance and pollution concentration. This is usually done every day, hence one series of data of absorbance for different levels of nitrates. Okay, nitrates are measured in milligrams per liter of water, so keep note of that. I'm just keep marking. This is what's nice about being able to write in books, is you can mark stuff off in the book as you're reading. Okay, so we got data on nitrates, data on absorbance, and the question is, it seems, okay, the absorbance is going to depend on the nitrates, which is my explanatory, which is my response. I'm going to keep on reading to see how to either verify that or to see if they're using it differently. Chemical theory says these data should lie in a straight line. If the correlation is not 0.997, something's wrong, and we got to do it again. Okay, B, the calibration sets nitrates level and measurements absorbance. The linear relationship that results is used to estimate nitrate level in water from a measurement of absorbance. Okay, so they're actually estimating nitrate level from the absorbance. So we're actually looking at the absorbance and then predicting how much nitrate's in there. So that makes the absorbance the explanatory and the nitrate level the response. Now, if you were more familiar with this process, you probably could see that sooner, but if not, then maybe not so much. And then it asks for what's the estimated nitrate level if the absorbance is 40, so we're going to use it to predict it, and then we want to see how accurate we're going to be. Okay, so let's take a look and see what we got here. Let's, for part A then, well, first of all, we're going to do this. Going to need to make we don't have to make a graph, but I'm just going to at least do this so I can remind myself what I'm doing here. I've got my explanatory then is the absorbance. And this is the nitrate level. And the nitrates are measured in milligrams per liter. And absorbance. Did they talk about what the absorbance was? Passing light through and measuring its absorbance. They didn't actually tell us how they measured that, did they? Okay. So let's put the data in our calculator and calculate R and see what we get. So I have already done that and put my data in my list. So L1 is my absorbance. L2 is my nitrates. So L1, L2, and I'm just going to go check and see if my diagnostic is on. There we go. So that I can get R on here. Whoa. Okay, apparently I don't know how to work this and make it stop. Unlock. There we go. Okay, so how's that for an online calculator here? So we're going to go up to diagnostic because that's what turns on and off the correlation calculation. And watch, it's probably already turned on and I didn't need to do this. You're just watching me do this. I apologize. Come on, there we go. There we go. So we'll just turn it on. There we go. So quit. So to find the regression line, second, quit. Okay, I go stat, calc, and reg ax plus b is fine. X list is L1 the way that I set it up. You may have put it in for L2 and L1, it depends, so check that. Calculate. Okay, so R is 0.999. We've got 0.997, so it should be at least that. It says plot the data, find the correlation. Must the calibration be done again? The answer is no. So we've got 8.8 minus 14.5. Just double check that. 8.8. Oh, X is the way I did it. Minus 14.5. Okay. Okay, so we've got that. Now we want to graph it. Remember how to graph this? Rather, I can plot it by hand, or I can do it on my calculator. Second stat plot. Turn it on. I've got my scatter plot on, L1, L2. My window, I'm going to check my minimum window for L1 goes from 7 to 226, so I'm just going to go from 0 up to say 250. Maybe go by, I don't know, tens. Let's see how that works. My Y's are going from 50 up to 2000, so we can go from 0, let's go all the way up to maybe 2200 and go by hundreds. Let's see what that looks like in that graph. Okay, that looks like it's pretty straight, pretty much on a straight line. And remember, if I want to do trace is nice because then it just tells me the exact data values, 47 and 400, 93 and 800 and so forth. Otherwise, there's your picture, so I can definitely come over here, put my scale down, plot my points, okay, and go from there. Okay, so make sure you get a good scale down, and I'm just kind of watching the time. Although we're getting this, we can put a good scale on. Let's look at that. So if I look at this, if I look at the scale, recall, I can actually probably better just to look at my data in my book and go see what my scale is. These scales, I was going basically from 0 to 250 for my X's, and I went every 10. So if this is up to 250, I could call this 50, 100, 150, 200, 250, and then this went up to 2000, so this could go 500, 1000, 1500, 2000, and so forth. Now that's going to change what my points look like, so it might be better, since I have a handful of points, to go ahead and just plot the data, because I got rid of my axis accidentally, and just say okay, 7 and 50, these are going to be tiny way down here, right? 50 and 7.5, or 7.5 and 50. Got a couple pieces of data down here. 100. 12.8 and 100. Up a little bit. 224, or 24 and 200. So then I'm getting up here. 400 or 47. I'm graphing 47 and 400. So now you can see where I'm going with this. Now when you have more data, you're going to do what I did before and just kind of plot them in there. This is probably a better way to go with the with fewer pieces of data. 93 and 800, 138 and 1200, and it's just a sketch, so we're just trying to be close. 183 and 1600. If I wanted to be exact, I'd pull out my graph paper and go to town. 2000. And 2000, and then 226 and 2000. Okay, so there's our sketch. Do I expect it to be accurate or not? I would expect it to be very accurate, since R is 0.999. My data is very close to a straight line. Absolutely. There we go.